A very important concept in business is the supply and demand. Now, we're treating these as functions, a supply function and a demand function. The supply function is a relationship between the unit price and the availability or the supply. And in general, we would expect the supply function to be an increasing function because the supply will increase as the unit price increases. And the demand function is a relationship between the unit price and the quantity that's demanded by the consumer. And this is a decreasing function we would expect since the quantity demanded decreases as the unit price increases. The higher the unit price is, the less demand there's going to be. And the price of a commodity is determined when the supply is equal to the demand, right? That's what's referred to as the market equilibrium, when supply equals demand. And we're interested in finding that market equilibrium. In the sense that if the price is too high, the consumer is not going to buy. But if the price is too low, then the supplier is not going to produce because it's not cost effective for the supplier. So we want to find where the supply is equal to the demand. This market equilibrium. To approach this, to find the market equilibrium, we can simply set the supply function equal to the demand function and solve for x. Here's a graph of an example of what these supply functions and demand functions would look like. Now, we said that the supply function is an increasing function. Right? So the increasing function, that's this curve here because it's increasing reading from left to right. So this is the supply function. And then the demand function is decreasing, right, as the unit price, where unit price is the x-axis. As the unit price increases, the quantity demanded will decrease. That's why it's a decreasing function. So this is the demand function. And we want to find this point right here. We want to find where the supply is equal to the demand. And that's what we refer to as market equilibrium. So we're going to look at an example to where a supply function and a demand function will be given, and we will be asked to find the market equilibrium. Okay, so in this example, we are trying to find the market equilibrium, the equilibrium quantity, right? How many units should be produced, and the equilibrium price. What should the price be in order to reach that equilibrium? All right, so we are given the demand function and the supply function. Demand is P equal negative x squared minus 2x plus 100. The supply function is P equal 8x plus 25, x being the units in terms of 1,000, and P being the price. Now, in some of the homework examples, you may not be given which one is which, or you may not be given explicitly that this is the demand function and this is the supply function, but you can know which one is which based on which one is the increasing function and decreasing function. We said that the supply function is the increasing function, and we would be able to look at this linear function, hopefully, and know that this is an increasing function because the slope is positive. And we know that the demand function is a decreasing function. Since this is a quadratic function, we know that the parabola opens down, meaning that's a decreasing function since a is negative, that x squared term is negative. Okay, but so to find the market equilibrium, we set the supply function equal to the demand function. So we are going to set negative x squared minus 2x plus 100 equal to 8x plus 25. All right, so what we're saying here is that we're forcing the price to be the same. Right, we're forcing, or this is the p-axis, right, for the price. We're saying that this price is the same for both supply and demand function. And when we solve for x, we'll find this point here. All right, so let's do that. Now, I have a quadratic equation. To solve a quadratic equation, we need to set the equation equal to 0 and solve for x by factoring or using the quadratic formula. So subtract 8x from both sides and subtract 25 from both sides in the same step to get the equation equal to 0. Negative 2x minus 8x, that's negative 10, and 100 minus 25 is 75. And in the next step, I'm going to multiply everything by a negative 1. Why am I doing that? So that my x squared term will become positive, because I like working with positive leading terms. So multiplying everything by a negative 1 will change the sign of each term. A positive x squared, positive 10x, and negative 75 equals 0. Now, can I factor this? Let's play around with this, see if we can figure out the factoring. I know the first term's got to be x times x because these multiplied equal x squared. And the last terms must multiply to equal negative 75 and add to equal 10. Let's try 15 and negative 5. 15 times negative 5 is negative 75. 5 plus negative 5 is a positive 10. That works. So we set each factor equal to 0 and solve for x. Now we've got two answers here. But in this business application, I can throw out one of these answers. That's going to be the negative number. I can throw out x equal negative 15 because I cannot produce negative units. So I'm only taking the positive number. Remember that x is in terms of 1,000 units. So I get this x equal 5, but in terms of the actual problem, the equilibrium quantity is 5,000. The equilibrium quantity is 5,000 units. That would be 5,000 units to reach that equilibrium quantity. And what's the equilibrium price that we'll set? So the price should be the same for demand and supply. So it doesn't matter which function I plug 5 back into, I should get the same answer. So I'm going to plug it into the easier one, the simpler one, which is the supply function, since this is just a linear function. So plugging 5 back into the supply function, we get 8 times 5 is 40 plus 25, that's 65. All right, so I should set my price to be $65 to reach the market equilibrium and produce 5,000 units.